I'm Professor Leanne Williams. So originally I'm from Australia. I spent a lot of my adult life in Sydney. How did I get into psychiatry and neuroscience? I started out actually studying clinical psychology. At the end of my training, I was actually really disillusioned. It didn't seem like we really had answers. So I, for a while, was a designer, making clothes and designing. And I ended up, I always had a fascination for why is it that people are so varied, like the individual character, and that basically we all live on the thin edge of the wedge. I mean, we all do. And so one of the positions, the jobs I was able to get was actually one of the first, it was kind of like an experimental program for moving people out of long stay wards in a psychiatric hospital, so people who've been there more than 30 years, moving them out into homes, normal homes in the community. And I worked there as a psychologist with people from other disciplines in a home where there's at least 9 people living together in a therapeutic setting. And our goal, we thought, was to provide therapy. And what I quickly realized is that we are facing, how do people deal with such real life crises when they're dealing with mental health issues, and how little we understood that we actually are crapshoot on the treatments that we're trying. Just a way to kind of understand what's going on. We don't have a way. We talk in these abstract models that people can't relate to. We don't make it concrete. And that drove me to go back to study. So from there, it was like I was on a mission to understand the connection between our brain and what we experience and what happens when we develop mental health disorders, and how can we do better at treating them. So I went from there to studying, and then very fortunate to get a scholarship to study then at Oxford University to do my graduate research. In the early days when we were developing biological models for understanding mental health. Stanford was one of those decisions that was like 100% clear. One of the very few clear decisions, moments of clarity in your life. And I came here as a visiting professor, and within, I guess, the first 2 days, I thought, I have to be here. I have to stay here. And the reason is a combination of just incredible quality of people, all in this concentrated space, and the concentration on, literally concentration on concentration. So a concentration of smart, good people in one very kind of tight community. So the opportunity to work across campus and then work with people who are very open to ideas and will say yes, and then will realize a vision very quickly. And I have not seen that anywhere else. And to me, this is the only place that you could realize a neuroscience-informed mental health model. We, within the core PanLab, within the core team, we're 25 people. We come from all sorts of different backgrounds, and we bring different expertise to the table. So that spans fundamental neuroscience, clinical neuroscience, software engineering, machine learning, clinical psychology, neuropsychology, psychiatry in kids and adults, brain imaging, and new statistical models. So very multidisciplinary. So the 25 of us of the core, and then we work together with a network of collaborators that span the campus of Stanford, span our community, and then we have international partners as well. The key in the research I'm doing that's changing lives is to actually connect neuroscience insights with the people at the front lines of care. So we have had this enormous gap between discovery about the brain and mental health and how we actually treat mental health. It's completely fragmented. So I set out actually more than 5 years ago to say I want to close that gap. And that means bring together special expertise, and I think my history of experience and what I've learned has made that possible. Like, how can you know about neuroscience in a deep way, but at the same time, how can you live in the real world to know how to apply this at the front lines? So the transformation was to actually deliver some of the tests that we've developed into a real world setting, and then ask that question, can we do better in predicting who's going to respond to one treatment versus another, rather than hoping that spontaneously the results will leap out of the lab and somehow get into the doctor's office. I had an experience of a young college freshman. She was hospitalized for quite severe depression and hospitalized on suicide watch. I saw her and gave her our biotype assessment. Based on her biotype, she had a type that said, actually, our current first-line treatments are not likely to work. So I guided her to a whole new type of treatment, which is a new brain stimulation. And within a week, she remitted, and she's doing really well. This is the experience I see a lot. So I would have someone at least every week reach out to me to say, like, they're desperate, basically. The treatment and the options are fragmented. Like, where do we go? Like, if our daughter, our son, our brother, sister, if they're experiencing depression, where do we go? Like, who do we talk to? Who do we trust? And then they find out that there aren't any tests. So it's like, how can we know whether depression is real, or what can we try? So that happens at least every week. I have like hundreds of people on a waiting list for our biotype assessment. I really want to get it out into the hands of our community, our doctors. In this case, the mom and the daughter reached out to me. She was, as I said, a college freshman, so she was out of town. It was her first time leaving home. That may be one of the stresses that triggered this kind of severity of this episode of depression. Her mom was desperate. Felt like many people do, that it's not okay to reach out and ask for help, and how can you ask this Stanford professor who's so busy? She did reach out to me. I'm very fortunate very glad that she did, and she was able to bring her daughter to Stanford, and we, within that first few days, provided the biotype assessment, which is an MRI scan of the brain. We take behavioral assessments, we ask about symptoms, we ask about history, and then we wrap this all up into a report, which is a lot of big data crunching to get that information into a report that is interpretable. We sat down together, the daughter, the mum, myself, we talked through the report, and I explained how we have these different biotypes, and that what we saw in the report was that her biotype fit this type. We call it rumination. It often means that there's a tendency to dwell on negative thoughts, and it's hard to break that circuit. And that interacts with the difficulty in feeling good. Like, if you've got that circuit ruminating, it's really hard to actually get that sense of feeling good back again. And that type suggests drugs are not going to work. It suggests other kinds of therapies are not going to work. So we made the decision between us, let's try this new form of treatment, which is an accelerated brain stimulation treatment, which is very new. And within a few days, she already felt like a new person, felt transformed, And we know now a week later that she's in remission. So that's the second breakthrough, has been to take the understanding of this incredibly, just miraculous way that our brain communicates, like the circuits that allow us to think and feel and experience, and then what happens to those circuits when we're actually experiencing depression or other disorders. How to take that information and make it understandable, like understandable to ourselves and to anyone. So the breakthrough was to develop this system, I call it a taxonomy, so a set of types that explain what does your brain look like when you're experiencing this emotion, and what does your brain look like when you're experiencing depression. And by doing that, I can talk to you about saying, here we can locate the source of your depression. It's not about your fault. It's about, now we can understand it and we can empower you to decide how to change it. One of the innovations was to decide from the beginning to collect the data using standardized methods, and that's meant over years I can keep pooling the data together. So we now have data on thousands and thousands of people, people who are experiencing depression or at risk. So with these large data sets, we've been able to develop this taxonomy of at least 8 different biotypes, or 8 different ways that depression can arise from dysfunctions in brain circuits. And then we apply that to asking that question of, can we do better? Can we do better for getting someone well? Currently, if we use a current approach, it's essentially a crapshoot. It's a one-size-fits-all, and only has 30% effectiveness. So that means only 1 in 1/3 of us will get better. Our success rate with our biotype model has a 75% success rate. Yeah, so we've more than doubled the success rate. If you convert that into what does that mean for the world, it means that we're talking at least 120 million people getting their lives back. So in order to develop these biotypes, you have to know how is the brain functioning in real time. Like, you have to be able to peer inside the human brain, look at the brain in action. And that requires some quite innovative new technologies for brain imaging. Myself and collaborators have developed these new techniques for being able to do that. And we call it looking at the human brain connectome. It's like, how are the circuits of the brain connected and how do they talk with each other? And we can do that very precisely now. So to the resolution of less than 1 millimeter, we can actually look at how the brain's reacting, how different parts of the brain are communicating, and that gives us a way to identify what type of brain communication do you have, or where there may be short circuits in that communication. It's important to integrate the brain imaging, the precision brain imaging, with other information, because we're talking about a complex disorder when we're talking about depression. So it's the integration of what is your genetic risk, how are your genes expressed, how are they impacted by life experience, and altogether, how does that determine how your brain circuits are functioning and how that becomes yourself, how that becomes you. So we, at the same time as focusing on brain circuits, because that's the proximal measure, the brain is the organ of interest when you're talking about depression, we also measure, for example, the whole exome, like all of your genetic variants, and we look at which ones are relevant to shaping the way your brain circuits function and how they're impacted by life experience. Our future goals are to look at other kinds of omics. So, for example, the microbiome is about your gut, like your gut flora, and changes in your gut flora can impact your brain's stress systems and your brain's emotional systems. So we very much want to understand that connection. To really make these biotypes worthwhile, we have to be able to predict outcomes for each person. We have to do it on an individual scale. To do that, we apply probabilistic inference algorithms, which allow us to predict with greater and greater precision as we keep accumulating our data. So we take a deep learning approach to training from our current data and then applying it with increasing precision and accuracy as we gather more and more data. And we focus then on interpreting the results at the level of the individual person. We really want to create technologies that make brain information accessible anywhere. And already we work with our engineering colleagues, for example, our chemical engineering colleagues, who have developed a skin-like sensor for quantifying brain states already in the natural world. We also use virtual reality to induce mental states and then acquire signals in those virtual reality settings. We want to be very mindful that our sampling sensors need to be able to guide interventions, to have the capacity to deliver interventions anywhere, and not simply be sensing sensors. Managing the vast amount of data we acquire is a challenge in its own right. It requires innovation in its own right and new computational architecture. To deal with this scale of data, we're moving to innovative cloud solutions, so developing computational cloud-based architecture for dealing with this volume of imaging data. And we couple that with architecture that operates massively in parallel. And that allows us to get from what used to take 5 months to process the data for one person to just 2 days or less. So we can turn around, for example, the integration of this kind of data into a report for one person now within a matter of hours. We really want to be innovators in biomarker-guided trials. We have already conducted the world's first international multi-site biomarker-guided trials in depression, and the successes from those trials are driving our biomarker-guided model and how it's applied in treatment. What we need to do now is apply these biotypes to guide what treatment works best for you at the level of the individual person. And we're already piloting biomarker-guided trials to do that. And we apply them with not only our currently available treatments, but with innovative new treatments of the future. So those would include, for example, these new brain stimulation techniques as one opportunity. Others would be apps that are delivered on your smartphone and can be accessed at home, all tied to this brain-based information. So there's obviously been a revolution in sensing and in passive sampling, and that's incredibly important to really realize a vision for mental health care and possibly other areas of complex care. It's important that people know what to do. Like, how do you act on this? We have these complex signals that we're now getting. We want to know what to do and how can we use them to improve our lives. People in our community are the ones driving this change. So we want to catch up to be able to give them information based on the sensors that can deliver interventions in their own settings, at home, in their natural world, and for them to know when does it make sense to actually come and see a doctor as opposed to make use of an intervention that's available in their home. In order to think about prevention for depression, we really need to think about getting in early. We need to get in early for detection as well as treatment. So we're pushing it back as far as we can, as early as we can, to look at where does the earliest exposure to stress trigger, for example, changes in brain circuits. How does that impact how we develop as kids? How does that affect how we socialize as teenagers? How does that affect how we deal with our stress and how we adapt to it as adults? All factors that can impact our brain circuits and put us more at risk, for example, for developing a depressive illness. Along with the scientific innovation, we want to do better for social justice. Right now, the narrative around mental health is often one of blame. With a neuroscience-informed model, there's an opportunity to change that narrative, so it's one of understanding rather than one of blame. And with a neuroscience model, it's a way for people to understand mental health differently, to see it differently. It's outside of yourself, it's tangible, we can see it, and that helps reduce stigma. We've seen that already in our grassroots translation into the real world. We see people have those moments of understanding, of deep empathy, of telling us, oh, like I see that while my brain may be broken in this place, I can change it. Or this is not about my fault. This is not about me not trying hard enough. And all those things make a difference. With this neuroscience-informed approach, we also have a way to foster the way we talk about it more broadly. So that could be with families, with caregivers, with our wider community, a way to talk about mental health in a different way. We also want to do better in terms of getting our care into more diverse populations to address inequities and not create them. We want to be the catalyst for training our best future leaders in this new field. Stanford is known for having the best students, but also students who think about the whole picture, all of the person. And that's what this new field requires. And Stanford has all of the concentrated preeminence to make that a reality. I'm here, and I'm sure my colleagues are here. In fact, I know my colleagues are here because of the quality of our people, how open we are to ideas, and how quickly we can realize a new vision. So right now, we're the number one in realizing this new field. And just like in Silicon Valley with startups, they need to be first in market to stay ahead, to stay number one. And that's exactly what we need to do. The time is now.